Hi everyone, welcome to our webinar today. The topic for today's webinar is the future of electrification and what it means for clean energy. We have with us an excellent guest speaker today, and we also have with us on the line our host for this webinar, Warren Leon. Warren is the Executive Director of the Clean Energy States Alliance, also known as CESA. This webinar is being presented by the RPS Collaborative for CESA. And we'll get started in just a minute, and I'll pass it over to Warren. But before I do that, I'd like to go over a few quick housekeeping notes. All of our attendees today are in listen-only mode, so hopefully you can hear us, but we can't hear you. You've got a couple of options to join the audio portion of the webinar. You can listen in using your computer mic and speakers, or you can connect using a telephone. If you'd like to minimize the webinar console so that you can view the webinar full screen, you can click on the little orange or red arrow that you see circled here, and that arrow also allows you to expand the webinar console if you'd like to. A very important note, we ask that you please submit your questions and your comments as you think of them throughout the webinar by typing them into the question box on the webinar console and hitting send. We will save about 15 minutes at the end of our presentation for a Q&A with the audience, and we'll get to as many questions as we can. We do expect to have a lot of people on the line, which means a lot of questions. So to make sure that we get to your questions, type them in when you think of them. Don't wait until the very end. And a final note, we are recording this webinar, and we'll post the recording on our website probably this afternoon. We'll also send you a link via email with a copy of the webinar recording and a link to a PDF of the slides. And you can also find those materials posted on our website at cesa.org/webinars. And all of our previous webinar recordings are also available at that link. So with that, I would like to turn it over to our host for this webinar, who will be introducing our topic and giving you some background information. And like I said earlier, our host is Warren Leon. Warren is the Executive Director of the Clean Energy States Alliance.
Hey, thanks very much, Samantha. Let me first tell you all a little bit about the Clean Energy States Alliance. We're a national organization composed of state energy agencies and other public entities that are interested in advancing clean energy across the country. And you can see logos of our various members up there on the screen before you. And one of the things we do at Clean Energy States Alliance, if you go to the next slide, Sam, is we coordinate the RPS Collaborative. This is an effort funded by the Energy Foundation and the U.S. Department of Energy to allow state RPS administrators, federal agency representatives, and basically anyone else who's interested in the wonderful world of RPS to share information and ideas and to learn about what's going on. We do webinars like this one. We have a monthly newsletter which talks about news related to state RPSs, and we produce reports on a variety of topics. To get on the mailing list, just go to the link at the bottom, go to our website, cesa.org, and look for the page on the RPS Collaborative or RPSs, and you'll find a way to sign up. If we could go to the next slide, I want to bring to your attention the fact that we at CESA do a lot of webinars, and over the next month or two, we have a very large number coming up and some pretty interesting ones. You can see them all here, everything from blockchain technology for RECs and tracking systems, that's one for the RPS Collaborative, to things having to do with peaker plants and battery storage, resilient power, PV finance, some really excellent clean energy programs that just won State Leadership in Clean Energy Awards. So go to our website and sign up. If we go to our next slide, I'd like to now turn to introducing our speaker. We're really delighted and honored to have him with us today. Dr. Francisco de la Chesnaye is Senior Program Manager for the Energy and Environmental Analysis Group at the Electric Power Research Institute, or EPRI. His work focuses on modeling of the U.S. energy system and especially on the electric power sector, and he does this to evaluate the possible transformation of the system under alternative policies. His most recent efforts include leading EPRI's National Electrification Assessment, which we're going to hear about, and now moving into state-level studies having to do with electrification. In addition to his research at EPRI, he has served on various external expert panels, including for EPA Scientific Advisory Board panels and National Academies panels. He's an excellent speaker, and the work he's been doing on electrification is very important, so I'm delighted to turn things over to him. So you're on.
Thank you very much, Warren, for that very kind introduction. And I'm very happy to be back speaking with CESA. I had a really positive experience at the Chicago meeting. I guess it was like a month and something ago. And I'm very happy to go over EPRI's National Electrification Assessment. To start off, I'm going to cover the overview of the national assessment and then also talk about the work that we started doing at the state level with EPRI's members. To start with, on the national assessment, we wanted to take a look at where the most significant opportunities existed for electrification. So we looked at how the economy uses energy from the end-use perspective, by sector and by technology. So a bit of a graphical representation is what you see here, which is the 2015 composition of final energy. This is from the Department of Energy data, where the energy by technology and sector is sort of color-coded. And the easiest way to sort of, I think, understand this is if you look at the top, where we have cars and light-duty trucks, where the majority of the final energy fuel consumed is petroleum liquid fuels, gasoline and diesel, and that's about, I think, 15 quads of energy. From our perspective, when we did this study, we said, well, that represents a significant potential to move from the use of liquid petroleum fuels to electricity through the deployment of electric vehicles and plug-in hybrid vehicles. So we took that same approach for the rest of the major subsectors and technologies, and you can see sort of the mapping in front of you there. And again, this was done at the national level, and now we're moving into the state perspective. So to do the analysis, we started out with this robust set of technologies we have in a database, but we also wanted to look at how the energy economics play in, and that's really from the consumer's perspective. So at EPRI, we have a model, it's called the U.S. region model, where we started looking at power generation from the state perspective, where we essentially have what we call electric dispatch model. So for each of the states, we're meeting electric demand at lowest possible cost, which also includes not just generating power within the state, but also the ability to trade electricity across states, given that that's a tremendously important feature of our electric power sector. Now, in order to do the electrification analysis, we needed to combine the electric generation part of the model with what we call an energy end use part of the model. And if you go back to the last slide where I talked about the representation of specific technologies by sector, but now we have to add in the consumer perspective. Sort of how do consumers make choices about technologies, which include a whole range of specific factors for those technologies. I mean, just think of the choices and the way we buy our cars these days. But a really critical, important factor is also to take into account the economics, and in particular, the relative prices between fuels, between the price of electricity and, say, the price of natural gas when you're considering buying a furnace or a heat pump for your home. So we started with the detailed technology database. We now have what we call a sort of comprehensive energy system model of both the supply of energy, particularly electricity, and how consumers use technologies and make choices about energy consumption. And then the next thing that we needed to do in order to do the assessment was to come up with a range of different analytical scenarios. We started with 4 scenarios, which we thought covered a good range of the possible outcomes in looking at this national level electrification potential. And I'm not going to go through all of the details here, but I just wanted to show you that in any kind of energy economic analysis, there are some really important inputs and assumptions that go into the modeling of the work. What I want to focus on here is the reference projection or the reference scenario where the policies that we have included are really only those that are on renewable portfolio standards. Those that are in place and those that we know of over the next couple of decades. But moving to the right, in terms of the progressive and transformation scenarios, the main difference in those is that we applied a carbon price, which is really a proxy for some potential future climate policy. We didn't model any particular policy, but we use the carbon prices both across the electric sector and the energy end use, so that sort of all energy consumption sort of face the same carbon price. And in the progressive case, we started at a $15 price, whereas in the transformation case, we started at a $50 price. These two scenarios come close to, at least in the transformation case, sort of the 80% reduction in greenhouse gases that some policies sort of target. And then in the progressive case, it's about a 40% reduction from 2005 levels by 2050. And so I'm going to go forward in the presentation and just sort of focus on the reference and those 2 other cases. So in terms of total final energy on the results, one of the key things that we see is final energy in our projection, in our scenario for the reference case, is actually declining. And for comparison, we have mapped in the Annual Energy Outlook 2017 reference case. Now, the major drivers for the difference between EPRI's reference projection in this study and the AEO is that we have significantly more energy efficiency occurring throughout the economy, mainly in the electric use of technologies, but also in other energy-using technologies. And then on top of that, we do have our electrification in the different sectors in transportation, residential, commercial, and industrial. And then that leads to a further deviation in total final energy from the AEO, particularly the further you go out. If you just want to look at the electric sector or electric demand in terms of final energy, while we have total final energy going down, we do have electricity demand going up. Now let's break this down into different components of final energy. So on the left-hand side of the chart, we've got total final energy. Again, this is in quads, starting in 2015, going out to the end of the time horizon. And we've got electricity, then natural gas, other non-electric energy, which is primarily petroleum-based liquid fuels. And you see that same trend we saw before, where the total, the top of the colored bars, the colored areas, is declining over time, while we do see an increase in electricity. On the right-hand side, we're going to shift over to terawatt hours, since we're focusing on electricity, to see what's the makeup of that increase, which is primarily through the use of electrification in vehicles. We do see some increases in buildings and industry, but the main driver is in the transportation sector, such that in the total, we have an increase in electric demand of over 32% between 2015 and 2050. Now, at this point in the presentation, I usually get some questions in terms of, well, what's driving a lot of those changes in the transportation sector? And remember, early on, I described that we're taking a very much of a technology and an energy economics approach to this. So that means that costs matter to consumers in the decision making. So in this slide, we see what the annualized costs are between electric vehicles and internal combustion engine vehicles, and sort of two scenarios of driving intensity. But particularly in the high driving intensity, you see that EPRI's projections, which can be in some ways seen maybe optimistic for electric technologies, that we do have the total cost for electric vehicles declining and sort of becoming lower around 2022, 2025, and then continuing a lower trajectory out to 2050. So this is an example of how the economics play in and how we're modeling this behavior sort of from the consumer side. Now, to go from the reference case, which we just saw, to the progressive case, we see the same sort of general trends. Final energy continues to go down, but electric demand or electric share of final energy is also increasing. And here, same dynamics, but with that carbon price that starts at $15 in 2050 and increases to about $100 by 2050, we just see more of electrification, particularly now in buildings and industry. And if we want to look at some of the details in the transformation case, where the carbon price reaches about $300 in 2050, we see that, let's say on the left-hand side, the share of electricity to final consumption of energy almost approaches 50%. And part of that is because we have much lower final energy than we have in other cases. And then the growth of electric demand and the use of electric technologies is now a little bit more evenly spread between vehicles, industry, and buildings. But again, this is a scenario where we have a really high carbon price and we're approaching 80% reduction in CO2 in the energy sector by 2050. So some of the other key important takeaways from this study include, and this was a bit of a surprise when we completed this study, was that total demand for natural gas increases in all the scenarios that we ran. And you can see in terms of the quantity of total gas consumption, how those change over time in the 4 different cases. Now, even though they do increase, even though natural gas does increase across the board in all scenarios, the reasons for the increase differ depending on the scenario. In the reference case, we see a continued use of natural gas in home furnaces, and as the economy continues to grow, we see that dynamic. However, in the case where we have a carbon price, and again, the carbon price is applied both to the electric power sector and to the rest of the energy end-use consumption sectors. Here we see natural gas playing a major role in clean power generation through the combination of natural gas plants with carbon capture and storage. And to get a little better sense of that, we can look at the results from electric generation. So the picture across the 4 different scenarios is very different in 2050. And we have a comparison of the different power generation technologies that are color-coded between the 4 scenarios, and then providing a perspective to 2015 power generation. And the metric here is annual terawatt hours. And I want to draw your attention particularly to the progressive and the transformation case and the numbers at the bottom, which is essentially a CO2 intensity. So this is tons of CO2 per megawatt hour. So that in the progressive and transformation case, we have decarbonized to a great extent the power sector. And if you look at the carbon capture and storage part, that's again with natural gas. We also see increases in new nuclear power generation and also, of course, in renewables with wind and solar. But across the board, we continue to see a diversified generation. We do not have a scenario where we have the majority of generation one technology, right? We do not have a 100% renewable scenario. And again, we're doing this in terms of a cost minimizing capacity expansion of the power sector. And a diversified generation portfolio is something that continues to come out in EPRI's results. Now, this is one of many generation mixes. You can think of other scenarios where carbon capture and storage may not be feasible, either from a technology perspective or the costs may be higher than we anticipate. The same thing for nuclear power. But if we remove any one of these options, for example, if carbon capture and storage was not as cost effective as we modeled here, then other generation technologies would have to fill the gap, whether that would be new nuclear power or more wind or more solar. Now let's look at CO2 emissions across the 4 different scenarios. And remember, we have captured here CO2 emissions from electric power generation, and that's the blue part at the bottom. And then mainly those non-electric energy emissions, primarily from transportation, but also from the use of fossil fuels on the energy end-use consumption in residential and industrial. And then listen, we focus at the reference projection. And remember, there's no additional greenhouse gas policies. We only have renewable portfolio standards on the power sector, and then no other policies across the economy. There's no carbon taxes, there's no greenhouse gas limits. We're not modeling any of the state initiatives, whether it's California or New York and others. But even in the reference case, through the use of clean energy generation from the power sector and then using that to electrify the other sectors, primarily transportation, we see total emissions going down, even though the emissions from the power sector are flat or even slightly increasing. So this is, again, an important takeaway that the use of clean power generation from the power sector to then electrify the rest of the economy will result in net CO2 emissions reductions. And then to drive that point even further, in the cases where we have a carbon price, again, as a proxy for some potential future climate policy, we see the continued decarbonization of the power sector to then drive more emissions reductions through electrification in the rest of the economy. So, in summary, the key messages that come out of EPRI's National Electrification Assessment are mainly four. And the first is that we see a continued trend of electrification. In the last century, in the 20th century, because of the industrialization of the U.S. economy, we saw a rapid transformation and a rapid development of the power sector and then the use of electricity and final energy consumption. That trend sort of leveled off for the last decade or so. But now what we see, driven by technological change, sort of increased performance and lower cost in electric technologies, then driven by customer choice, that electrification trend can continue out for the next couple of decades. Energy efficiency is also a major and important component in what we see in the use of final energy, both in terms of energy efficiency and the use of electric technologies, but we also see important gains in energy efficiency sort of across the board in other sectors as well. I talked about natural gas and how natural gas remains a critically important fuel, both for end use of technologies, but also electric power generation, as it continues to support that sort of cleaner power generation in terms of greenhouse gases. And then lastly, given the transformation that we could see, both on the energy consumption and the energy technologies from the consumer's perspective, but also how the power sector responds to those changes, we see a continued need for better electric sector resource planning. And then I also showed the potential changes in greenhouse gas emissions across the scenarios. And along with that, although we didn't provide the results now, we also expect that there would be important air quality results, not just from clean power generation, but again, through electrification of the rest of the economy, seeing improvements from air pollution reductions in transportation and industrial and commercial emissions. Now, of course, this isn't going to happen all by itself. At EPRI, we continue to see the important role for technology research and development, which is the mainstay of EPRI's work. But there are also important economic signals that need to go out between the different sectors and also from the consumer's perspective so that they can make those decisions that would mirror some of the results that we have here. And as I think we mentioned earlier at the beginning of the webcast, EPRI completed a national assessment, and now we're in the phase of working with our members to implement a very similar analysis, but now at the state level. And we've sort of broken those projects, those state-level projects, into sort of four major tasks: an energy system assessment, an environmental assessment, and that also includes air quality analysis, and a high-level transmission assessment. And those first three tasks will be focused on providing results at the state level. So, for example, we're working in the state of New York and the state of Illinois and Wisconsin. We'll be providing those results at the state level. We've added a more specific utility task to the project where we not just go from the national level results to the state level results, but now we're going to go and dig even to a more detailed level at a utility service territory and providing that critical technology assessment for those electric technologies that have the biggest bang for the buck, again, from the consumer's perspective. But we're also working with our members to develop long-term implementation plans for electrification programs. One of the other things I wanted to get to, and it's a key component part of the state level studies, is the ability to look at not just how total energy, in particular electric demand, changes, but also how the shape of the load curves can change over time because of the way that we're able to evaluate specific electric sector technologies by sector. And so this is an example of what we call our Northeast Central region, and it's those states that are colored on the map, and how we're looking at electric load over the course of the year, again, by major technology. And this is a very similar pattern I'm sure you're all familiar with, showing space heating, cooling over the course of the year. Then we've got non-seasonal load, which is primarily from the industrial commercial sector. And then in 2015, there's almost a negligible amount of electric demand for vehicle charging. But if we overlay our reference projection and look at the results for 2050, we see a very different picture. We've got significant changes, seasonal changes due to space heating with the deployment of electric heat pumps, but also vehicle charging. And because we're able to evaluate how electric technologies perform depending on your climate zone, for example, whether how an electric vehicle performs in Southern California versus up in the state of Washington, we're able to pick up these seasonal differences. And then to make the point about the importance of resource planning, given the potential transformations we're seeing both in terms of power generation and electric demand across different sectors, we can look at the aggregation of all those different loads. And in 2015, again, for this region, we see a pretty similar winter and summer peak. So if you're planning your system, you have a pretty good sense as to what are the capacity needs that you have. But again, if we overlay the results for 2050, now we have a very different picture where we're not just comparing the 2015 results to 2050, but now have a much different system in terms of a winter peak that is far higher than a summer peak. So we see that electrification will also impact electric sector resource planning. And this is one of the other key drivers for taking our analysis, working with our members at the state level. And in terms of where we're working, you see here that the states that are in green, we've got 8 ongoing projects at the state level. And we also have a range of other states, not just our members who are electric utilities, but also we have some interest from state agencies in terms of this analysis and how this analysis and looking at electrification and decarbonization could help different states meet either climate or air quality goals. We're working in 8 states where we have a goal of getting a total of 10, and we hope that we'll meet that goal within the next couple of months. For those of you who want to get all the results and all the details of the U.S. National Assessment, we provided the direct link to the report. And after you've had a chance to go through it, I'd be more than happy to take any additional questions on the report at a later time. I think you should have my contact information, which is right there. And I think with that, I'll wrap up and then open it up to any questions that we may have.
Hey, thanks very much, Francisco. We have lots of questions, some quite specific, some broader, and I'll throw in a mix of both of those. The first person asks, in what year does the $50 price on carbon kick in? And does the price escalate over time, or did you apply a constant 50-year price over the whole period of analysis?
So in the both in the progressive and transformation scenarios we ran, the carbon price starts off in 2015 and increases at a 7% real rate in both cases out to 2050.
Okay, but given that there's no carbon price in place now in 2018, how does that influence the results that you are assuming a price was already in place?
I guess it's a bit of a sort of a modeling artifact. The model runs in what we call sort of 5-year time steps. So we start the model in 2015, and then we get results in 2020, and then 2025, and so on. So yes, correct. And there is not a current carbon price right now, but at least it's the way that we can start to get results by 2020. And because we're just starting it in 2015, the carbon price effects haven't really kicked in very much at all.
Okay, well, let me ask then two broader questions that are related. One person asked, do you see widespread electric ground source heat pumps for space and water heating in the future? And someone else writes, I'm surprised to see the relatively small portion of building energy use that is electrified for heating, even under the transformation scenario. That doesn't seem to reflect the potential for heat pumps in almost all building types in all regions, and strong economies driven by continued efficiency improvements and current cost competitiveness on an operational and upfront cost basis. Why does your model, do you think, not show more electrification in building energy?
Well, actually, I think if I'm trying to actually go back to the slides, but I guess I sort of lost control here. But I mean, in the cases where there's a carbon price, I do think we show a good amount of electrification in the building space. It is primarily, it is through the deployment of electric heat pumps, and we modeled sort of different types, sort of hybrid systems and just the primary systems. And we do take into account sort of where you live or where the systems are operated in, because it's a critical component for the efficiency of the systems. So I would encourage whoever asked that question to actually go to the final report and look at the chapter that's specific to buildings, and then you'll get a much better sense as to the potential that we see going out, and particularly in the transformation and the progressive case.
Hey, Sam, can you put slide 10 up on the screen? Just so folks can see that. Then I have two other related questions. One is where you show continued strong natural gas use for electricity. One person asked, isn't there a potential that states will impose very aggressive RPSs that would drive a lot of that natural gas out and replace it with renewables? And then someone else asked, they're thinking less about the RPS market. Someone else asked, why did you not also consider growth in voluntary and corporate renewable energy, non-RPS energy, as a driver in the electric power sector, considering that the majority of new renewable capacity additions were made outside of state-mandated renewables in the past several years? Would you expect even more net CO2 reduction in the sector if this were to be considered?
So just in terms of the policy framework, we wanted to kind of keep it simple, or at least simple enough with the four scenarios that we picked, because we were looking at a national level picture. What we're doing now and working at the state level is focusing on those state-specific scenarios, whether some states are considering, and many states are considering, more stringent renewable portfolio standards, and that's one of the key components of the state analysis. And in some cases, we're also picking up on non-RPS policies that are also will have an effect on both greenhouse gases and air quality. So to answer the question, though, yes, if we're looking at more stringent RPS policies, we would expect CO2 emissions to go down. But natural gas will continue to play an important role because I go back to that diversified energy system, at least a diversified power generation system that we continue to see, and we've done additional analysis looking at the really high renewable mandates where we continue to see the importance of natural gas, and I'm happy to follow up with sort of additional research that EPRI's done on that.
Great. And where do you get your estimate that carbon capture and storage will become viable? One of the people writing in thought that that seemed quite optimistic and unrealistic. What's your source for assuming that it will become viable?
So one of the great benefits of being an energy economist at EPRI is that I've got about 800 other people that are working on the technology part of the equation that I rely on to get cost and performance information on power generation technologies and energy end use technologies. So all of the principal assumptions that we use in our modeling come from EPRI. And you can go to, I'm happy to follow up with those. You can go to our model documentation, or there's even a public-facing report we put out that provides EPRI's sort of summary on the cost and performance of all power generation technologies, nuclear, fossil, and renewables.
Okay, and this, again, is going, a lot of these questions actually in different ways get at issues having to do with natural gas, whether it has to do with carbon capture and storage or its continued use. And somebody asked, do you have any comments on the potential effects of concern about the global warming potential of methane emissions from natural gas extraction and transportation? Will that possibly drive down demand for natural gas?
My comment there is, yes. there's methane emissions through the entire natural gas production cycle, from extraction, distribution, all the way to the end use, wherever that end use may be. Methane is a powerful greenhouse gas. It has greater sort of heat trapping capabilities in the atmosphere than does carbon dioxide. And but that also means that reducing methane emissions can also be a cost-effective alternative or approach when you're looking at, again, a sort of more comprehensive mitigation strategy. We did not look at, in this study, we did not look into that. My group at EPRI has done a lot of work in the past on looking at opportunities for methane mitigation, whether it's in the natural gas sector or the coal mining sector or in the agricultural sector. So again, I'll just say that, we recognize in our analysis, our economic analysis, that, methane mitigation can be an important cost limiting factor for a comprehensive approach, and we continue to do research in that area.
Thank you. Does your assessment include any analysis related to hydrogen fuel cell vehicles and the potential market share for fuel cell vehicles and what that would mean for EV deployment? And if you didn't do that, why not?
So we did not do that. I guess the reason we didn't do that is mainly that we, at least EPRI, we don't have as good a handle on the potential costs for moving in that direction. Hydrogen fuel cells and the hydrogen part of the energy economy is something that's on our, sort of long list of research topics. But at this point, we didn't have the same, say, level of confidence in our, back to, where do we get our cost information from? We were much more confident in our estimates and projections for electric vehicles and that infrastructure that would be needed for electric vehicles. And we just didn't have that for as full a scale deployment on hydrogen fuel cells at the current time.
Okay. And I know you're just now getting into the state studies, but do you expect to see significant differences in which fuels are displaced over time by geographic region?
My initial assessment is that we're still going to continue to see that the electrification of transportation is going to continue to be one of the major contributors to both electrification and to the reduction of greenhouse gases and improvements in air quality. But I will say, though, that every state's energy mix is different, obviously depending on the state's economic and industrial makeup. And so we will see differences in the electrification potential, particularly in buildings and industry, depending on which states we're evaluating.
Okay. And as you said early on, you are showing some considerable continuing improvements in efficiency over time. One person asked whether your analysis considered rebound effects and the difficulties of sometimes getting some of the efficiency improvements that one hopes to achieve.
So because we do take sort of an energy economic perspective, again, from the customer, from what's the customer choices, where prices are an important part of those decision making, we are capturing some of that. But again, it's something that's, I think, going to vary depending on the sector and then, of course, even by the region.
Okay. And somebody asks about what your modeling assumes about the development and implementation of energy storage technology over the study time frame. That's a type of technology where the price has been coming down rapidly. Is there a chance that price reductions will be greater than you modeled, and therefore one could end up with somewhat different results?
Well, absolutely, and I would say that I think one of the limitations of the study is that we don't have a fully integrated energy storage sort of technology in what we've done so far. It is something we're very much investing in now, both with EPRI's energy storage program, but also using that cost and performance information and this economic modeling approach. But yes, energy storage and the larger deployment, larger scale energy storage with continued price declines will be an important factor that we're looking into, not just from sort of the total impact, particularly on, say, power generation, but also if you think back to those load curve shapes I showed before in terms of resource planning, energy storage, could have a significant potential to also, has to be considered in terms of the longer term resource planning.
Yes. Well, here's a question that goes to those load shapes, and someone wanting to make sure they were understanding it correctly as you were presenting it. It appears that there was seasonal variation in electric vehicle charging expected in your projections, with more charging expected during the winter months and consistent demand during the rest of the year. Is that correct? And if so, why is it?
So that is correct. And it has to do with the seasonality sort of was picked up. And I guess if we can go to slide 18, I think it is, or at least slide 18 in my deck. Well, there we go. Yeah. So what we're picking up is two things. The first is that in our analysis or modeling of the energy end use consumption, we take where you live into account, and therefore the climate that you face. So it's sort of my example of whether you have a electric vehicle in Southern California versus the state of Washington, and that it's going to be colder in the wintertime in Washington or even just in Northern California, and that in colder weather, the vehicle recharging rate of a vehicle is going to be less. And that's what we're picking up here.
Okay. Thank you. Well, I just had a problem that I lost my question box, but while I'm trying to retrieve it, let me see if I can remember a couple questions that you asked, that people asked. One person was asking about, for the reference case, could you explain again, why didn't you just go with the Energy Information Administration's, their reference scenario? Why did you start from a different starting point?
Sure. So can you go to slide 6? So we thought it was important for this study to actually create our own reference case. We are a consumer of the excellent work that the Energy Administration does, but we found that particularly for energy efficiency projections, we had a different perspective. And so we essentially started with the AEO, but then added on our own estimates and projections for energy efficiency. And then we ran our model given our projections of the deployability of those electric technologies. And remember, this is a reference case. There's no policy here except for like the state renewable portfolio standards. So from EPRI's perspective, I guess you could say we're taking a more optimistic perspective on electric technologies and how consumers can use those over time.
Okay, good. Is there the case, given that even your reference case is a significant reduction in energy use from the Energy Information Administration's projections, is it the case that if you had that scenario on the screen, would people be saying that, looking at it and saying, hey, your projections for the transformation case are so dramatic, they're hard to believe? Are there reasons why people think we can really get to that level of reduction?
Yep. Yeah, this was very similar, I think, to a question I got in Chicago. So remember, the transformation case starts with a $50 carbon price and increases to $300. And again, it's meant to approximate that 80% reduction in CO2 emissions from 2005 levels by 2050. Because that is a policy scenario that's sort of been in the works for a while, we thought it was important to use that as sort of, one end of the range of scenarios that we modeled. So it's EPRI isn't indicating or saying that we think this is where things are going to go. We just wanted to provide that perspective that if you wanted to approximate or get close to this 80% reduction goal, what would it look like, not just from the power generation side, but from the total energy system side? How feasible that kind of a stringent climate policy would be is really not up for me or EPRI to put much opinion into.
Okay. I have just a couple more questions I'm going to ask because we're nearing the end of the hour. And then, Francisco, I'll give you a minute or two to say anything else you want to say you haven't had a chance to say up till now. One person asked, given your projections for natural gas and all these different scenarios, does that imply the need for more natural gas pipelines?
Well, given the projections we have in terms of the increase use of the consumption of natural gas, then there would need to be a proportional expansion of the system. We did not do a detailed natural gas infrastructure assessment, but again, as we showed, in all those scenarios, we do see a continued increase in the final consumption of natural gas.
Good. And my last question for you is, when will people be able to see some of your state results? When will some of that become public?
So let's see, the majority of the state studies were initiated, let's say, in the sort of second quarter of this year. Most of the studies have about a 24-month period of performance, although I think we may have some of the results of the early tasks available, I would say, towards the end of this year or the beginning of next year. So that would be about the time to do it. I mean, I just want to reinforce that, this is comprehensive energy system we're doing at the state level, you know, power generation and how energy flows through the economy and how energy is being consumed with those, you know, technological detailed assessments. So it's a lot of tough work, but we're very fortunate to be working with our members and some state-related agencies. And I do hope that we have material to share towards the end of this year or beginning of next year.
Great. And do you have any famous last words before we close? Any points you want to reemphasize or anything you wish someone had asked but didn't?
No, I just want to express my appreciation for the opportunity to talk to everybody, all of the participants and all the members here. And I would just say that you know, the offer to follow up in any specific questions from this or the national assessment, or if in particular there are you know, anyone at the state agency level or state level who wants to know more about the state studies we're doing, to just please contact me and I'll make sure you get the information you need.
Hey, thanks so much for making the time for us today, for doing this excellent presentation. It really is an important study which provides data that, you know, people clearly can quibble over it, but it still is a good modeling exercise that gives a good starting point for thinking about the future of the electricity sector. So thanks very much. And for all of you on the line, I hope we'll have you attend future webinars from the RPS Collaborative and the Clean Energy States Alliance. So thank you very much.